Here it is a little bit more difficult problem because the point of interest, in this case, point E, where we are asked to find the internal reactions, lies between two supports. So it doesn't matter which side we select now, we have to deal with the support reactions first. So as we can see, we take again to find those internal reactions. We have to find to take a cross section, and we can take either the left or the right because even though here it says that we have a smooth thrust bearing on the left side, which introduces an axial loading there, like we can see there, as opposed to the journal bearing on the right side in the point C. This introduces only a radial uh, reaction CY, and there it doesn't matter that much because we don't have any other reactions along the x-axis. So in this case, bx is going to be equal to 0, so we can select either left or right. Of course, if we would have an axial, then we will have more work if we select the left side. But as we said, we have to deal first. It doesn't matter which side we select, we have to deal with the support reactions. Suppose, so for that way, we can build a free body diagram and all as an overall problem. And we put the support reaction, we isolate in this case, the shaft there. And we start to analyze the reactions there. Of course, if we're gonna select, say, the right side, then we are not interested in the left. So in that case, we're interested to find CY. For that, as you can see, is not good idea to solve for forces along the y direction in order to see why, because we have these two unknowns there. And the simplest way is to take the sum of moment in along the point B, because we eliminate by in that case, and that's what we are doing it. We are after cy, and as you can see, we have this 400 pounds pulling the beam downward around the point, tending to rotate this beam around point B in a counterclockwise directions, which we selected as a positive in this case direction. So that will be positive 400 pounds times 4 feet there. And then we have the cy also is giving us its, although it's pushing upward, it rotates the beam around this point B, as we see there, in a counterclockwise direction again. So that will be also positive. And this time we have 8 feet the force, the arm there. And then we have this 800-pound force at point D pulling downward. This is acting in a clockwise direction about point B. And of course, the moment that will be negative, and the moment armed will be 12 feet. That's between B and D. Uh, one equation, one unknown, Cy. We solve for it, we get Cy. Now we are ready to focus on the point of interest, which is our point E, and we select the right side because we worked for the CY. So again, we draw the free body diagram, and again, I highly recommend don't skip these steps with the free body diagrams. So here, by observation, we can see that EX, it's gonna be 0, and that's what we get if we write in the second law. And then again, if we look at EY, sum of forces along the Y direction, and I selected it upward, I should have probably by observation look here, and I should have get it downward because 800 needs another 200 to balance this 1000, which I kind of put it there. But that's the point, that if it's negative, then we just need to change the direction. So I put it here 200 pounds downward. And here we have sum of moments about point E. Easy to solve. It didn't matter if of course, we would have selected about point D with, or point C will still have same idea similar like this one. And so because we will still have one unknown, so we have a minus. The way I put it there, it's a negative direction clockwise. I selected counterclockwise as positive, that's negative. Then this one, it's rotating in a counterclockwise, that would be positive. So we have 1000 times 4 feet. Then we have this one is clockwise, which is negative. So 800 times 8 feet. Again, we solve and we get negative 2400 pounds feet. Or if we want to change that sign, we eliminate it, and we see that it is counterclockwise acting it. If it's positive 2400 in the counterclockwise direction. I hope this is also clear. Like in a little bit more work, a little bit double almost the work, as if we compare with the previous problem where we had a free end, and we could have used that way to simplify the work. In the next problem, I'm gonna select a problem where we have an axial loading. So we have to deal a little bit with trig functions in order to find the axial component and the vertical component. All right, so I hope you have a good day, and if you have questions, please let me know.